Every movement you make requires energy. Walking, lifting, sprinting, even standing. That energy doesn't come from motivation or talent. It comes from biology. At the center of that biology are four things: your heart, your lungs, your muscle, and oxygen. Before we talk about performance, fatigue, or recovery, we need to understand how they work together. Oxygen is something we breathe in every few seconds, but its real role is energy production. You inhale oxygen, your lungs transfer it to the blood, your heart pumps it to the muscles. Inside each muscle cell are mitochondria. They turn fuel into usable energy. Carbs, fats, lactate, they are all fuel. But without oxygen, energy production becomes limited and short-lived. With oxygen, energy is sustainable. Without oxygen, fatigue builds quickly. This is why oxygen availability determines how long you can hold a pace and how well you recover. Oxygen during exercise. As intensity increases, muscles don't just need more oxygen, they need it faster. If delivery can't keep up with the demand, the muscle begins to deoxygenate. You may still look fine from the outside, but internally, the muscle is approaching its limit. Fatigue doesn't start at the whole body level, it starts inside the muscle. We often think of a muscle as a motor, but it's more than that. Muscle is a metabolic organ. It consumes oxygen, it produces energy, it generates fatigue at a local level. Each muscle is different. It differs in fiber type, capillary density, mitochondrial capacity, and recovery speed. That means that two athletes can perform the same task, but different muscles can be the limiting factor. Traditional metrics look at the body as one system. Heart rate, VO2, lactate, they tell us how hard the system is working, but they do not tell us which muscle is struggling. The body doesn't fail as a whole. Performance fails at a local level. A cyclist doesn't stop down because his heart stops. A runner doesn't stop because the lungs quit. They slow down because specific muscles can't meet the oxygen demand. Whole body metrics react after the problem starts. They don't tell us where it started. If fatigue happens at a local level, we should measure at a local level. When we measure the muscle, we can see how fast oxygen is consumed, how deep the deoxygenation goes, how well recovery happens, and therefore we can identify limiting muscles, left and right asymmetries, inefficient movement strategies, and we can detect these even when the external performance still looks stable. Instead of guessing, we measure. Muscle oxygenation reflects the balance between supply and demand, how much oxygen arrives and how fast it's being used. When we measure muscle oxygenation, we are measuring the metabolic cost of movement. This changes how we test, prescribe, and manage training. To summarize muscle oxygen, oxygen explains how energy is produced, muscle explains where performance is limited. In this video series, we'll show you how measuring muscle oxygenation turns that understanding into practical decisions for training, testing, and performance.